Hi guys, welcome to another episode of MrLopezClasses.com. In this episode, we are going to talk about battery switches, and we are going to talk about battery isolators or ACRs or battery stabilizers or battery equalizers. All of them have the same function, and we are going to explain right now what is the meaning of the ACR and what is the meaning of the battery switch selectors. The battery switch selector. The battery switch selector is a switch interrupt the current. For that reason, always in the back of the battery switch selector, you have only positive cables. You interrupt the power coming from the battery and entering into the panel, or coming from the battery and entering into the start motor. This is a switch. Alright, there are two types of switches, and they are classified according with the capacity in amps per hour. One of the switches is a simple on-off. On-off. Power coming in, power coming out. The positive enter here and the positive goes out here. And simple, I on or off is an interrupter. It's like a breaker. It's exactly the same. This is on-off. And this one is for two battery banks and parallel. What is the meaning of that? One input from the positive of the battery bank number 1 and other input from the positive of the battery bank number 2. Input and input. And this one in the middle is the common, is the output. Oh, battery bank number 1 coming in, battery bank number 2 coming in, and this is the output coming out. For that reason, you found that position 1, position 2, parallel. Position 1, position 2, and parallel. The capacity of the battery switches is in amps per hour. For example, in this particular case, they say the capacity is 250 amps in the label in continuous operation and 350 amps in intermittent operations. What is the meaning of that? Yes, if I connect this switch selector in parallel using both battery banks, this equipment support 250 amps in continuous operation. If I work with one or the other one intermittent, support 350 amps. 350 is the capacity of the battery bank. In other words, with this battery switch selector, I can work with two battery banks at the same time with both of them with no more than 250 amps at the same time. Or if I use this switch only in position 1 or position 2 independent, I can support 350 amps per each battery bank. This is the capacity of the battery switch selector in amps per hour. How can I select my battery switch selector? I select my battery switch selector according with the capacity of the battery banks in amps per hour. Okay, how I know what is the maximum capacity of my battery switch selector? You added the capacity in amps per hour of both battery banks, and you added 10% additionally, and this is the capacity in continuous operation that the switch selector should be supported. Simple. The capacity of the battery switch selector depends on the capacity of the battery banks. All right. Can I use the battery switch selector for one battery bank gel and the other battery bank lead acid? No problem. This is independent. This is only an interrupter. Yeah. This is not according with the type of batteries. No. This is for any type of battery you can use the battery switch selector. It's not specific for a specific type of batteries. Yeah. This is can be used for multiple battery switch selector. What is the procedure to test my battery switch selector? Is simple. The only that you need check is continuity. You need check continuity with your multimeter, and you check continuity between position 1 and common. You select position 1, and right now it's selected position 1 should be continuity between position 1 and common. Beep, or no beep. And right now I select position 2. Beep. Okay, this is the procedure to verify if the switch is working or not working. Is with the continuity in between the position and the output. The position and the output. That's simple. That's the procedure to verify. What happens if I use my switch selector for a battery bank with higher capacity than the capacity of the battery switch? Simple. In any moment, internally is broken, is interrupted because the high temperature, the high current increase the temperature and destroy the plastic and destroy the breaker, the switch, the battery switch selector. Yeah, the enemy of the battery switch selector is the temperature. And the temperature increase inside of the battery switch selector when the amps increase, when the amount of amps are superior than the capacity of this device. This is basically the theory of battery switch selectors. There are a lot of manufacturers for battery switch selectors. You can select any of those manufacturers if the manufacturer is marine approved. All right, we have the battery switch selector, and there are two types of battery switch selectors. This one is if you work with an independent in one side and independent in the other side. And the next one is the battery switch selector that I explained in the previous example. One input coming from battery 1, one other input coming from battery 2, and this is the output. One output going into the panel, and the other output going into the start motor. Okay, this is good. This type of battery switch selector is excellent when you use the cranking batteries only to start the engine, and after that you switch to the house battery. There are different type of automatic charging relays. This is the ACR. The ACR is an equipment, is a device, an electronic device used to keep the charge of both battery banks stabilized equal. In this particular case, this battery charger have one input and two outputs. The input is the power coming from the alternator, or is the power coming from the battery charger. And this is the output connected to the positive of the battery bank number 1, and this is the output connected to the positive of the battery bank number 2. And what is the idea? This element, suppose that I have a single engine boat in board with one alternator. Okay, that alternator supply power for both battery banks at the same time and keep both banks with the same level of charge, equally charged. Oh, what is the recommendation if I use this ACR? Try to connect battery banks with similar characteristics. For example, this battery bank is a battery bank of 250 amps, the capacity. The second one is a battery bank of 250, both of them similar characteristics. And both of them lead acid and lead acid, or gel and gel, or AGM and AGM. But depend of the charger that you have, if the charger is appropriate for those battery banks. The secret is try to select battery banks with similar characteristics in order to keep both battery banks equally charged in equal conditions. This is very important. Right now I am going to explain the battery chargers, and we are going to understand how should be selected the alternator or the battery charging according with the capacity of the battery bank. This element is located in between both of them. This element, this is an ACR with one input and two outputs. There are other ACRs. There are other ACR like this with two inputs and three outputs. What is the meaning of that? This one, you can connect in this input one alternator for starboard engine, and in the second one, the other alternator from the port engine. I have a boat with two engines, alternator 1, alternator 2, and I have three battery banks. A battery bank for starboard engine, battery banks for port engines, and battery bank for generators. That's a perfect ACR. With this ACR, I have three battery banks equally charged. I can use all other similar to this one to keep other 2 or 3 battery banks equally charged. Yeah, this is for 2 inputs and 3 outputs. There are other ones similar to this one with 3 inputs and 4 outputs. Okay, the capacity in amps per hour of the ACR is according with the capacity of the battery banks connected to the ACR. For example, this one said that the capacity is 80 amps. 80 amps. Okay, this is the capacity, 80 amps per hour. Right now we are going to try to understand what is the meaning of 80 and how fast can I charge a battery with an alternator of 80 amps or 60 amps or 40 amps. What is better? In what situation is recommended bigger capacity or less capacity? Right now we are going to talk about that. Okay, but in this moment we are concentrated on the ACR. I have 2 alternators coming in and I have 3 battery banks. This equipment, this ACR, have the ability to keep those 3 battery banks equally charged with the same level of charge, with power coming from, in this particular case, 2 alternators or 2 battery chargers or 1 battery charger and 1 alternator. What is the idea? For example, we are going to do the diagram right now to connect this one for 1 input and 2 outputs. All right, this is the diagram that we are going to connect. I have 2 battery banks. I have 1 battery bank here, that's the positive, the negative. Remember, all the battery banks, the negative should be connected together. The negatives should be connected together and connected with the negative bus bar, and the negative bus bar connected to the bonding, and the bonding connected to the sink. We are going to learn about that in the chapter number 10 dedicated to bonding system. All right, I have here the battery switch selector, position 1, position 2, and this is the common. Okay, from the positive, I enter here. From the positive of the second one, I enter here. All right, and I have the ACR. The ACR, I have the alternator number 1. This is the alternator of a starboard engine. And I have the alternator of a port engine, and I have the ACR here, and I have the ACR here, and I have the ACR with 2 inputs, and 3 outputs. All right, I am going to connect 1 input. This is the output DC of the alternator, and this is the output AC. Remember, the output AC of the alternator, we are going to learn later in the next episode, will be used to connect the tachometer. And this is the output DC of the alternator, and this is the output AC connected to the tachometer of the other engine. Okay, this DC output should be connected here. And this DC output should be connected here. All right, and I have 1 output here connected here, and I have another output here connected over there. All right, and this other output is free. in order to connect other battery bank. And this is the procedure. I have one source of power. I have other source of power. And I have the ACR with 2 inputs and 3 outputs. What is the advantage of this design? In this design is excellent. What happens if, for example, the alternator number 1 is broken? This one. With only one alternator, I can keep both battery banks charged, fully charged, equally charged at the same time. Yeah, this is the advantage of that system. And the ACR supply power for both battery banks coming from only one alternator, the alternator that is working. This is the advantage of this particular design, of this particular example. And if one alternator is broken, the system could be charged from the other alternator that is running. Of course, depending on the capacity of the alternator, you need select the alternator appropriated in order to keep the batteries fully charged in a short period of time. This is the idea. Recover the charge of the battery as soon as possible. We are going to talk right now about that situation. All right. This is the other example about the battery isolator. This is exclusive for one engine. I have the alternator, the output of the alternator, the output DC of the alternator enter in the middle of the isolator, and from one side to battery 1 and from the other side from battery 2. Enter in the positive of the batteries. Enter in the positive of the batteries. The negative is connected to the negative bus bar. All right. This is the procedure to use the ACR, this particular ACR with 1 input and 2 outputs. I have another ACR, for example, this one. This is excellent. I love this picture. Is this isolator. Yeah. This ACR, this battery isolator or ACR. This one is exactly like the ACR that we have on the picture. Let me, I follow the diagram. I have one battery bank, I have other battery bank. The positive of this battery bank enter in the position number 1, and the positive of the second battery 1 enter in the position number 2, and from the position number 1, I connect the position of this ACR, and from this position, I connect the other position in the ACR. And internally, I connect position 1 with position 1 and position 2 with position 2. What is the advantage of that design? Of course, the output of this ACR is connected with the big positive on the start motor, and the output of this other ACR is connected with the big positive in the start motor of the second engine. And in this way, okay, and from the alternator of this engine, one cable is connected into the position number 1 of the ACR, and from the output of the second alternator is connected with the position 2 of the ACR. In this particular case, if one alternator is broken, with this alternator, I can keep both battery banks, this and this, properly charged. If the other battery alternator is broken, with this battery alternator, I can keep both battery banks fully charged. This is an excellent design. This combination of a battery switch selector is perfect in order to start both engines from one battery bank, or both engines with 2 battery banks at the same time, or one engine before and the next engine after. This is the perfect combination in order to use 2 battery banks and 2 switch selectors and 1 ACR in order to combine the 2 battery banks with 2 battery switch selectors with 1 ACR in order to use both battery banks at the same time from one switch, or both battery banks at the same time from the other switch, or both of them at the same time from both switches. This is excellent in a medium and big boats with double inboard engines, gas or diesel. That picture, I recommend that check the picture, follow the picture, and you can use that picture in the future. This picture is exactly the explanation about this with one input and two outputs. If you check, the input here is coming from the alternator, and you have one output connected with position number 2, and the other output connected with position number 1. Of course, position number 2 is connected with the battery 1, and position number 1 is connected with the other positive of the other battery. And this is exactly the same example when you use this ACR. The ACR should be mandatory. If you have more than one battery banks, and you have more than one source of power, the recommendation is use ACRs in order to keep the charge of the different battery banks equally stabilized. For that reason, the name of this equipment is battery stabilizer, or battery regulator, or ACR, automatic charging relay. ACR, automatic charging relay. Okay, this is with one input and two outputs, and this is combined. Look at this. The alternator enter here, and the power from the battery charger enter in this position. Okay, one source of power here, other source of power here, and this cable connected with the positive of the battery bank number 1, and this cable connected with the positive of the battery bank number 2. In other words, if the engine is running, and my boat is disconnected from the shore power, I don't have a battery charger, I only have alternator. But with this alternator, I have both battery banks fully charged. When the boat is on the dock, the engine is off, no power in the alternator. The power coming from the battery charger keep both battery banks fully charged. This is a perfect combination. You can use this one or this one. This is exactly the same. This one or this one. Those ACRs, they have in the bottom three terminals. The first terminal should be connected to the ground. The second terminal is to start or stop the ACR, connect or disconnect. And the terminal number 3 is an LED that LED could be connected on the dashboard to indicate that the ACR is running, is working. It's simple. It's simple to install the ACR. Battery bank number 1, battery bank number 2, alternator number 1, alternator number 2, and one cable ground, and the other cable in the other side, the LED, to indicate that the relay is working. This is mandatory. Always install ACRs in order to control the charge of the batteries, in order to avoid overcharging, in order to protect the life of the battery banks. The life of the battery bank depends on the how fast you charge the batteries, how fast you discharge the batteries, and how you keep the level of charge on the batteries. And that situation depends of the ACR, and of course depend on the condition of the battery charger.